Okay, welcome everybody. My name is Mike Optis. I am the president of Veer Renewables, and I'm very excited today to introduce you all to veerEarth, our new web interface primarily for submitting and downloading wake map simulations. So, just to get started, earth.veer.eco is the landing page for the new interface. You can sign up for an account here, nothing too fancy, but if we use a default login for myself, this will bring us to the web interface. So a couple points here. You can see we have some major sections on simulations. This is where we are going to design our simulations and submit them. Section on turbines where we upload the power and thrust curves that we need for WakeMap, and as well as a short section that helps outline some of the steps for submitting these runs. So pretty short and to the point doc section, as you can see here. And the hope is that this is all pretty straightforward and easy to use without the instructions. So before getting into WakeMap, I wanted to share one cool feature we've added, the ability to have ERA 5 reanalysis time series data downloadable with the click of a button. So if you highlight the ERA 5 global picture here, the drop-down menu shows this data set, and why don't we just jump right to it and show you what's going on here. So you can see at a course resolution, we have these pretty large grid boxes covering the whole world, which is nice. Now, these aren't particularly useful on their own given the course resolution, but you'll see we get better and better as we zoom in. You'll notice that these aren't the native 0.25 by 0.25 degree grid boxes that ERA 5 uses. Those get pretty condensed and warped as you get up to the upper or very lower latitudes. So what we've done is to make things uniform. We're using this triangular grid box, which essentially then, when it comes to downloading data, grabs the nearest native ERA 5 resolution grid coordinate for that, that best matches this triangular box. So starting here, we're at a pretty low resolution, just under 2. You can see that as we start to zoom in, it's going to re-render and get to higher and higher resolution. And once we cross this threshold into or above 5, this is when we're going to have the ability to download time series data. So why don't we navigate to a windy spot near Oklahoma City. If we hover over a grid point and click once, we're going to get a pop-up which shows some core information for the grid cell, the mean wind speed, some stats that we want to show soon, but not yet. But the main feature here is this download time series button. So we can click that. It immediately downloads a 10 megabyte file or so, which if we want to get into it, there's not much to it. We've all seen ERA 5 time series data a lot. Just the 100-meter wind speed and wind direction, 2-meter temperature and surface pressure, going from the 1st of January 2000 on an hourly frequency down to the latest month, which in this case is a March 31st of this year. So not much more to it than that. We're going to improve this over time, but the nice thing is this is completely free. Um, don't need to pay to download time series data whenever you need it for your analyses. Now moving on to the main purpose of this interface is to handle the design submission and downloading of WakeMap results. So WakeMap results will live and die by the turbines that are being modeled, so we can jump right into that right away. This brings you to a new interface where we will either upload or tweak our existing power and thrust curves. So under examples, I'm showing 3 power and thrust curves using publicly available data. So we have an IEA 3.4, NREL's 5 megawatt offshore, and Avesta's 1.65. So these are already preloaded into the examples folder for you. And if we click on one, it just shows essentially what the power curve and the thrust curves look like, and more of a sanity check. If nothing else, that data look okay. And you can even see what the power data looks like in tabular form. So that's what that's loaded up, of course, that's not going to be sufficient for most runs. So what we need to do is define a new turbine most of the time, and then these are stored on your own account, not visible to others. So there's definitely the privacy embedded into this app, accounting for how confidential some of these curves might be. But essentially, you add a turbine identifier, so just a name that you want to give the turbine, additional description, a rotor diameter, and your rated power in kilowatts. Um, we add our data either by dragging here or clicking on this button. And we've also added a template, which makes it easy to understand what the data is needed. So if you wanted to see what we need for this data, you can just open up that. And in this case, we have just 3 columns: wind speed, followed by thrust, followed by power. Naming of the columns is not important. It's just making sure the order is right. And that's all that it takes for this turbine data to work in WakeMap. So a bit of heavy lifting off the start to get all your turbines that you'll need up and going, but then they are saved for additional simulations. And you'll find as you do more and more, you have less need for these new power curves. They're all available in your account. So once those are established, the real big part of this is setting up your simulation. So under new here, we end up with a new map interface with a bounding box, as well as some core data to get started with our domain. So we can name this, we're going to use some Texas Panhandle results or some data. So we'll name this a Panhandle test. We can keep this as it is for now. We don't actually have to specify lat and long or x and y extents right here. We can do that with this bounding box once we load our turbines, and I'll show you how to do that. Resolution is going to be a big part of the model. Obviously, higher resolution gives higher cost, but also better resolves wakes. So based on what the domain is, we're going to have or the domain size in kilometers. There's going to be sort of a targeted suggestion that you could take or leave, as well as options varying from 700 meters down to 6 kilometers, some of which get disabled depending on this grid size. So you can see if we made this extra big, we should see now all options come available. So a pretty simple way to design the spatial domain of your run. Um, an easier trick would be to start right with the turbines. So in this case, if we click on turbines here, we have an option to upload a CSV file just by clicking on it like that. Or to get an example of what it needs to look like, we can download another template. And again, this is probably going to be one of the bigger lifts for getting started, where we have to specify the lat and long coordinates of each turbine, the hub height, the turbine model that's going to match the string in our power curve table that we defined. And additionally and optionally, you can add a wind farm field. And what this is going to do is when we get to post processing, any grid cells that we extract or any turbines here that are associated with the wind farm, we're going to package that time series data together into a single wind farm file for convenience. So optional, but we can choose to name this final column. So why don't we go ahead and load that. So this is a example for Texas Panhandle that we want to run. We load that into the system. Everything's worked. It's reporting almost 5,500 turbines. So we're running quite a big domain. And we don't see it yet, but we get this option to basically say, do we want to basically zoom in to where those turbines were and recalculate the bounds? So a nice feature that if we click on brings us to the actual domain of interest. So you can see now we're in the Texas Panhandle area, if not a little south of it. So a pretty big domain, a lot of turbines to model, but this is something that you might be considering. Although for the most part, clients tend to want more targeted domains for looking at single wind farm impacts. In this case, we have a legend showing the different turbines that are associated with each wind farm. Of course, this isn't real. These turbines, the actual turbine models are quite different, but these are the ones that we're able to share publicly. So we've just assigned them each wind farm randomly to one one turbine model or the other. So once we're in here, you can see our lat long and X and Y extents have automatically adjusted. And if we tweak this further, maybe to save a little bit of money, make this a little tighter, you can see the fields start to respond. So you don't have to waste a lot of time in the manual entry part of the spatial domain. So once we're happy with the spatial domain, we skip this, but let's talk about the time frame. We can either select a typical meteorological year, in which case under the hood, Wake Map goes into the ERA 5 reanalysis data at the center of the domain, and it looks for individual months that best represent the long term. So like January 2019, for example, and then followed by February 2006, for example. And that's done on the fly, based on whatever data is underlying at your site. Alternatively, you can select a custom date where you specify your range, and that's pretty standard as well. So we have our time period. Let's go with a TMY. We have our turbines. We have an additional option now to add virtual met masts. So in cases where grid cells that don't have turbines are of interest, like if you were building a wind farm here, for example, and you wanted to understand the impacts of the surrounding turbines, you might want some data here. And this is where the virtual met mast comes into play. We also have a template. It's a little simpler. It's just Latin long needed. You can look at that on your own time. But in this case, we're just going to upload a very small virtual met mast file. And you can see here, we've selected 5 additional points where we want to extract time series data. So we got our virtual met masts. We're choosing this option to extract time series at each turbine location, which is going to be a pretty big lift given the size of this domain. And we're off and running. Our last step is to select the heights, if any, where we want to extract WRG files. So we can select 80 and 120 meters, for example. So this gets us down to the end, showing what our grid cell count is at our selected resolution, in this case 2 kilometers, and what the estimated price is going to be. So we break that down in terms of the core simulation cost and additional fees for the time series and WRG extraction. And in general, these aren't very expensive, but because we're extracting 5,500 turbine time series data, this gets a bit high in this case. Very quickly, if we wanted to pivot to a 1 kilometer run, we should see the price increase quite a bit. So this would be a big domain to run at 1 kilometers, coming at 1,500. But if we thought 3 was sufficient for some broad studies, now it gets even cheaper. Now we're at 345. So once we're happy with what we have, we can save. And then this launch button becomes available, which we can then launch. We get a warning here because we're about to spin up a cloud-based computing cluster, and we want to make sure we're okay with the eventual bill that's going to come. And we hit start. So that launches. We can wait for the official notification here. Usually just takes a few seconds. Out we go. So now you'll see a new folder here called simulations, and this is our panhandle test, which we can go back in and visualize. Note that now that we've submitted the run, this domain gets locked. There's no more editing. We're basically in a post-launch phase, if you will. So that's going to take, a few hours, maybe a day, depending on compute availability for a given time. Once it's done, this is actually what the example on our interface is showing, the Texas Panhandle here. So eventually you'll get an email saying the run succeeded. We have our info here that matches what we submitted. And if we go into this run now, we get the same visualization. We'll get more visualizations as this interface develops. But the core deliverable right now is a single file with a zipped tar file essentially, which is going to contain our WRG data and our time series data. So we can probably go right to that folder once we download it. I'll show you just quickly what that looks like. We have a turbines and our VMM locations, more for reference in case we need it. And then we're going to have three folders with our WRG, so our 80 and 120 meters that were produced. And then we're going to have two additional time series folders. POR stands for period of record. So this is the actual direct output from the simulations. And you can see because we labeled those different turbine coordinates with different wind farms, we're going to get all those wind farms listed here as separate files. So in here, I've queued up the Sweetwater time series data. And you can see here for our TMY, we had January 2019 selected. If we go down the list, by the time we get to December, the algorithm chose 2007 as the most representative. And this basically has all, any and all fields you'd ever want: air density, potential temperature, wind speeds, wind direction. It kind of keeps going down the list if we were able to navigate it all the way down, showing some wind speed data there. And this would also include the power data output from the wind farm that's summed over all the grid cells that contain that wind farm based on that turbine's input file. So our last folder is called long-term time series. So what we're doing here then is taking that power data over our specific period of record, and then using the ERA5 data to develop a regression relationship. And in this case, we're using a random forest machine learning model, and then extrapolate that to the full ERA5 time series period of record. And if we were to open Sweetwater again there, note that this looks a lot like the ERA5 data initially showed, so the same fields directly taken from the ERA5 grid cell at the center of your domain. And then we have an extra power field coming from the period of record for that wind farm that now has been trained and extrapolated from 2000 all the way to present. So that's basically where WakeMap and veerEarth is at right now. So hopefully an intuitive web phase interface to get you started, a little bit of legwork to get the CSV files in order for submission, but then from there, pretty smooth operating. As things develop, we will add a lot more features such as layout designs and default power curves and default turbine layout parameters throughout 2024. We'll get that going. But in the meantime, a pretty decent start for interface we hope our clients enjoy. So thank you much for the time, and uh, let us know if you have any questions on this interface.